So what we've got in question 76 is we've got a pendulum swinging backwards and forwards through a small angle. And what that small angle statement means is that the equation in the textbook that relates the period of a pendulum to its length is valid in this case. So if the angle through which the pendulum was swinging wasn't small, then the formula wouldn't work. But in this case it does, so it's all good. So we have this pendulum swinging backwards and forwards. Its motion repeating every 1.25 seconds. So that means in this case its period is going to be 1.25 seconds. And we want to know how much longer should the pendulum be made in order to increase its period by 2 seconds. So in this case, we know that when the period is 1.25 seconds, let's call that T1, that's going to be related to the length of the pendulum by this equation here. So we have where T1 is 1.25 seconds. And now we want to find out how much longer the pendulum has to be made in order for the new period to be T2 is equal to T1 plus 0.2 seconds. That's going to be 1.75 seconds. And so in this case, the same formula gives us that the period in this case, so in the longer case, is given by the new length divided by g. And all we want to figure out is how much longer L2 has to be than L1 in order for this to be the case. So really what we want to do is to solve this equation for L2 and this equation for L1 and figure out how much longer L2 is than L1 by subtracting one from the other. So if we just divide both sides of this equation by 2 pi, we find this. And now to pull L2 out of this square root, we just need to square both sides of the equation. So if we square both sides, we end up with this. And finally, to get L2 on its own, we just multiply both sides of the equation by g, which gets us to this. And so we can say similarly, well, if we solve this equation for L1, we're going to have exactly the same thing as we did here, except with T1 in the place of T2. So we can just say similarly, L1 is going to be equal to g times this T1 divided by 2 pi squared. And so now to find the difference in these two lengths, we just subtract one from the other. So we're going to have L2 take away L1 will just be equal to g T2 divided by 2 pi minus g T1 divided by 2 pi. And just to be a bit fancy here, we can simplify this expression because both terms have a common factor of g divided by 2 pi squared. So we can just factor this out and bring in a set of brackets. And this gets us to just this common factor multiplied by T1 squared minus T1 squared. And if we just plug this into the calculator then, we're going to get g, 9.8, divided by 2 pi squared, and then multiplied by T2 squared, which is 1.75 squared, minus 1. Sorry, that's not right, so I've made a mistake there. This should actually be 1.45 squared, sorry, 1.45 seconds. So let me just correct that. 1.25 squared. So I get that we need to extend the pendulum by 0.13 4 meters in order to increase its period by 0.2 seconds.